My name is David Longbottom. I'm the founder of Construction Automation. We're a startup business and we aim to build standard houses using standard bricks, blocks and mortar. Construction automation is a widely used term that covers a whole raft of procedures and methodologies. I'd like to focus on Mark Farmer's report, Modernise or Die, where he went out and defined 7 modern methods of construction. On-site robotics, of which we are aiming, is modern method of construction 7. So that is the on-site robotic construction of houses. In that sector, there are a number of different methods. There are people innovating, doing 3D concrete printing, where basically they co-extrude concrete to a plan, normally by putting up a framework over the house and then moving a nozzle, extruding concrete as it goes. There is a business in Australia called Hadrian X, who have developed a large block and using a specially formulated glue, then assemble those blocks to the plans. They do that by putting a long arm that reaches across the site to make that happen. Why are we doing these things now? Well, in the UK, we've had a target for many years of 300,000 houses per year. And targets of this type, where it's a need rather than a want, if one year you don't achieve 300,000, it doesn't disappear as a want. These are needed. So if every year we don't produce 300,000, which is the majority of years, we need to produce that many more houses next year, which all adds up to we are chronically short of houses. If you take out the COVID years, we're building about 210,000 houses a year. If you go look at the patents, and we've achieved patents in Europe, America, Australasia, and Canada. And part of that research, you've got to go back over 20 odd years. And people have been talking about construction automation, laying bricks for dozens of years, back to the 30s and 40s, 50s even. What has changed now is technology. We are now in the digital world where you can scan things, you can make digital models of things, and mortars can be driven using encoders to incredible accuracy. You can also measure things very accurately with lasers. And combining lasers with digital motors with a digital version of an architect's plans means that you can control exactly to the millimeter, or to be honest, more accurately than the millimeter, what you're actually building. And also we have the computing power to do it. There's a lot of talk about the housing shortage, but I think it is incumbent on us to build houses of a decent quality. Houses that last, houses that are well insulated, houses that people want to live in and build sustainable communities. We've made errors in the past, building tower blocks that have got a shelf life of 50 or 60 years, building modular houses that have got design life of 60 years. This cannot be right. We will always be chasing housing stock. And the idea in 50 years, we're going to pull down 200,000 houses and replace them, I just think does not work. We need houses that last. So this is a picture of the robot. What we do is we put a track down where the scaffold will go. We are very keen to eliminate people working from heights. Working from heights is over 50% of accidents on building sites. So the track goes down, the machine sits on the track, it comes out of a container, effectively sitting in the front garden, and it goes round and round, followed by a skilled person on a person riding lift that will do the pointing, put tie bars in, lintels, and key components. Right? If the house has got blocks, we'll put 2 courses of blocks, 6 courses of bricks. If it's a timber frame house, we'll just go put the bricks up against the timber frame. Why bricks, blocks, and mortar? Bricks, blocks, and mortar have got a design life of over 150 years. When you build them, they're there to last. You can get mortgages on them. It attracts finance. In 100 years, you look at houses built 100 years ago, you can still go out and get a mortgage on them with no problem at all. There is a high thermal performance. A high mass house is a good way of insulating when it's very cold and also keeping heat out when it's very hot. There's benefits in the circular economy. With a brick house, you can go put an extension onto it. It's very easy to adapt and to alter. You can recycle bricks. Even at the end of its life, if you want to go change it, you can recycle it. And using standard bricks, standard blocks, and standard mortar, we can get an HPC sector, which we have for the machine. And this is not a novel product. It's what people expect to buy and live in. There is a deeper thing happening. So the robotic machine can just go lay bricks faster, more efficiently, but the digital transformation brings a whole new world in. If you take the architect's plans, and this is what the plan is showing here, what it's showing is that every 4 bricks, the machine moves. So every single brick will be assigned a digital number. So you will know exactly where you should be at any point in time. That brings productivity improvements. It brings continuous improvements in the build schedule. It guarantees quality. As you go around, it will prompt the skilled person to put a tie bar in or any other component. And as the machine comes back around, it will take a digital photograph. So whether that be a building inspector, that be an HPC, or whether it be a surveyor in 100 years' time, you can go back and look at the digital twin and see how the house has been built. The gentleman stood to the next to me is Dr. David Tan, Dean of the School of Architecture, Computing and Engineering, University of East London. And if you look at what we need to do to make houses to be better insulated, installing sensors to ensure that houses are thermally sound, do not get damp in them. The digital world brings all those possibilities into play, so you can monitor houses for the long term. So to sum up on-site robotics, bricklaying robotics, we increase productivity. The machine is fundamentally as fast, putting a brick down every 15, 20 seconds as a person, but obviously doesn't stop, doesn't get tired. It just continues working. And with a robot, if you know where you are, you can then bring in continuous improvement, manage the speed of build, and you will know in 2 weeks' time, you can go put the windows in or move on to the next stage. We improve health and safety. Apart from the obvious things about people picking up bricks, putting up down blocks, and the physical hard work of it, which the robot replaces, we eliminate working from heights. We reduce movements on site. This changes dramatically how a building site works. By accurately recording all the data around it, from the temperature, the wind speed, where the brick's being laid back per millimetre, taking digital photographs, we build a whole plan up which stays with the house through its whole life as a digital twin. That guarantees quality. And crucially, in this day and age when we are very short of staff, it closes the skill shortage gap. The Construction Industry Training Board, the CITB, did a survey of school leavers, and construction was rated 4 out of 10 for people wanting to go into the industry. The current industry is not attractive to the digitally savvy school leaver. But with a robot, you can build a house with a tablet, not a trowel. That changes the game. It makes a whole different diverse workforce being able to go into the industry and build houses. Construction automation has got patents in America, Europe, Australasia, and Canada. There is a quick picture of our in-house software team, design team, and me doing a demonstration of the costing model to prove the payback on the machine. We have an HPC set. Mark Farmer from Modernise Our Die has seen the machine, and there is Neil Jefferson, House Builders Federation. Thank you.
David, thank you very much for that presentation. It was a really interesting and intriguing topic. I think the idea of walking along past a new build development and seeing the walls being made by robots is really exciting. You mentioned that the technology is here, and also obviously there's the need for many new houses. What do you think is needed in terms of making more house builders or encouraging more house builders to use robotic bricklayers?
Mark Farmer titled his presentation "Modernise or Die." Now, it's not as severe as that. This is a big, wide industry. Our aim is to make 5 machines a week. So after produce the machines for 5 years, we'll slowly be producing about 15,000 houses a year by robot. So the way I see this happening is that 1 or 2 house builders, and there are a number that are very keen on it. Dave Smith from St. Modwin, Oliver from Barrett, Carla Holmes, have all expressed interest in seeing the machine operate. And so we will see the slow uptake by the industry, and then slowly trends will change over a period of time. So it's evolution rather than revolution.
And how do you think we can prepare our workforce to be able to work these machines? Obviously, we still need the skilled human workers, but at the same time, we might need them to be trained in a different way.
That's an excellent question. When we do publicity, I get some college lecturers coming back and say, we're destroying jobs. But it's a bit like the transition into electric cars. We will have diesel vehicles around us for 20 or 30 years. So there'll be a need for the current people to be upskilled to Euro 6, Euro 7 engines, for example. But if you're a student, you need to know how to work safely on an electric car. It's exactly the same as technology moving into this sector. There is a figure that 30% of kids at school will do a job that currently doesn't exist. And our education systems need to deal with this moving technology.
Yeah, perhaps people won't be out of jobs because of the robots themselves, but if they don't know how to work them. What about some of the other examples of robotics in construction? Do you think there's much need for drones or exoskeletons, for example?
I think they break down into 2 or 3 different areas. The drones using LiDAR sensors to digitally map areas is a complete change. It stops errors being made, and if you interlink that into the digital world, that's a whole pattern of the digitization. Exoskeletons, things that aid people's work, is I think what we need in this generation. People starting work at 20 and having bad backs at 40 is not acceptable. It never was, and we need to think about how we operate so that people live long, healthy working lives. So this is a big, big industry with many dimensions to it, and we are chronically short of houses. It's not just in the UK. You talk to people in America, Australasia, Europe. This problem is across the Western world. So for every sort of technology that can make a bit of difference here and a bit of difference there, as I said earlier, this is evolution, not revolution.
Well, thank you very much once again, David, for joining us at Show Home Live.
Fantastic. Thank you very much.